Good morning, everyone. We are very happy that you are here in Budapest and that this final meeting can take place here. It is my pleasure to introduce Ákos Horváth, our Director General of HUN Center for Energy Research. He will not just provide some welcoming words, but also provide some insightful views on the future of nuclear research, nuclear horizons in Europe. So, Ákos, thank you very much.
Thank you very much. Good morning. My name is Ákos Horváth. I'm the Director General of the Center for Energy Research at Post Institute this time. So it is my pleasure to welcome you in Budapest, and I wish you a very fruitful meeting. And using my time slot, let me speak a little bit about the general scope, the general view of nuclear research in Europe, and also connecting somehow our activities. The Center for Energy Research is a research center with 3 scientific institutes, and Balázs is working in one of them, and even the director since this January. But we have some other activities, not only the nuclear and nuclear safety-related activities, but also other energy-related activities, energy security, environmental physics. And also we have a strong institute in material sciences, in nanostructures, functional materials, etc. So just before the presentation starts, so I have a few slides about the general scope, the general view of the European research, as I am also taking part of the Science and Technical Committee of the European Commission, where those matters, the Euratom organized research, are also discussed, and we are forming a kind of committee opinion for the European Commission, where the directions are going. So this gives me also the opportunity to have a broader look on the European research. But myself also, I took part in this research. I'm a material scientist from the beginning, and my research topic was the radiation damage in structural materials. You know, these are steel structures, right? Pressure vessel in a nuclear reactor. They are getting neutron radiation. So these matters. So in this presentation, I would like to start with the general picture. As everyone knows very well that the recent years, the small modular reactor concept came up very quickly, and this is a very positive sign also for us. But I would like to underline the importance of the so-called Frank-Bogovic report, which was presented at the highest level of the European Parliament, the European politics. So this report also tells reports that the public perception is changing, and there is an importance to follow these SMR concepts, to join and form the kind of industry alliance behind it. Other political situation is also well known with this present geopolitical situation, which somehow influenced very much the energy prices and the kind of energy crisis, at least for a short time, but it will have a longer influence as well on the market. And in Europe, we have a very strong, relatively large portion of EVR user countries, and they most probably will have to change their fuel, the origin, the country of origin, for their fuel. So it will also implicate some changes in the let's say the short term. Then we have to deal with it as well in our energy prices and energy market. And of course, behind all these, or in just parallel to that, we have a very strong renewable energy penetration in the electricity market. But because of the nature of that energy source, we also need a very strong, a good, let's say, good solution to balancing the grid problems, the energy grid problems, And we all agree, I mean, in this room it is not a surprise, but we all agree that nuclear energy is an absolutely good solution if we take seriously the green transformation, and on the other hand we would like to balance the grid, then nuclear energy is a good answer for that question. So this is the geopolitical and energy market survey of the present problems. And after that, I would also tell you that in Europe since 2007 this so-called Sustainable Nuclear Energy Technology Platform exists, which is a body organizing the research and, let's say, giving us the main directions. This platform, of course, consists of the researchers themselves from the academic universities, and as it is a technology platform, it also invited the industrial users and the policymakers as well. So this is the technology platform concept is also existing in other energy areas, energy industrial sectors. But in nuclear, it's also a very good vehicle to draw the future directions of the nuclear research. So what we see that if we would like to transform our energy system to this fossil-free direction by 2050, then we need more nuclear. Presently, we have this 15% around. This doesn't look like too much, and so in the future we have to deal with not only with the present generation of reactors and the present technology, but we have to think about the other questions as well. I mentioned the problem of the supply of the fresh fuel. It is not only because of the geological problems, but also we have to deal with anyway with the question of the uranium sources. So we have to think about the far future as well. Then, at the same time, maybe at the moment it is not an urgent problem, but the spent fuel management is critical, and we have to do research in that direction. Probably the main milestone will be at the end of the century, so we have enough time to prepare ourselves. But the management, I mean, it kind of recycling of the spent fuels, not only storing in a deep repository, but also thinking about the recycling, because then recycling also can solve our question on the supply of the fresh fuel. But this is not an urgent problem, and we have to do research in that direction. And the innovative reactor designs, which serve us to provide this technology, then we have to deal with it. And presently in Europe we have only very few projects, and we don't see the industrial interest behind it. This is the problem. So Sustainable Nuclear Energy Technology Platform is organizing the research and describing the main directions. And what is the strategic research agenda now? This is a very general form, let's say, so it is not very surprising. This graph shows you the age distribution of the present fleet of reactors, so it also gives you a picture that we have a quite old fleet, above 40 years. So one of the urgent questions is how to operate them longer. Anyway, so on the long term we have to change them for maybe a new technology. So of course the safety, so the safe operation of the present fleet is the number one topic, because we have a fleet already. The fuel supply, as I mentioned, it is partly because of this future question of the uranium, but also because of in view reflecting to the present, the recent accident in Fukushima. We also speak about the new tendency in the accident tolerant fuel direction, and the sovereignty question of this Russian origin that we would like to change, replace the Russian fuel to something else, and this also implicates some technology questions. On the long term, we can nominate a few, but maybe not an exhaustive list of challenges. So the further aging of the plants, it can have some new questions what we don't see at the moment yet. And the stabilization of the grid, as I mentioned, that the penetration of the renewables in the energy market implicates a lot of questions. It means that we should use our nuclear reactors not only as a base load, but probably in a load following method, and this implicates a lot of challenges because of these structures of them. Then of course, then we have to deal immediately with the financial efficiency, because if you don't use baseload nuclear power plant, then we arrive to this question that how it will be financially effective, and also it implicates a lot of question on the maintenance, etc. So the inspection should be also improved somehow for that. And this extended use of the fleet also implicates question on the possible use of them not only in the electricity production but also in the heat market. So cogeneration is one of the questions. So then we have to speak about the new builds, because we hopefully see some of them coming up, and the construction time and the cost also tells us that something is maybe wrong with these big reactor designs, because it takes too long time to build them, and then the risk, the financial risk, is coming with this construction time. So probably this was one of the reasons why small modular reactor concept became so popular, because they offer a kind of better management of the reactor building. Decommissioning, of course, will come in the picture. This is maybe not an urgent, but very important part of the picture. So these, I don't want to go in detail, but all this you can find in the so-called New Guinea vision paper. New Guinea has 8 working groups, and they deal with the different technological aspects of that. Maybe for this group in the room, it's not very important to look all this, because radiation protection is not, let's say, not very well mentioned here, but of course radiation protection is all behind all those topics which are mentioned here. So I don't want to go in detail, because more or less I told them. And also in my presentation there are some slides I would like to introduce you here, but maybe we can share it later so you can look at it. This is just an example that even nuclear is considered as an old technology. I don't agree with that, but sometimes we hear. Then we also can show to the public that we have continuous innovations in this technology, in this industry. Even with the existing nuclear fleet, we think about continuous innovation. And then this is an example that once we investigate the pressure vessel, which is getting old and getting more damaged by neutron radiation, then we innovated. I mean, the research community in Europe innovated a new method which helps us to reuse those samples, those steel surveillance samples, which are used for monitoring the aging of the pressure vessel. And the problem is that at the beginning nobody designed this pressure vessel over 30 or 40 years. So they put a certain number of samples inside the pressure vessel, which was used for monitoring the aging. And then when we decided to extend the lifetime of the pressure vessel and the whole nuclear reactor, then we faced the challenge of how we can monitor even after. So we cannot put fresh monitoring material inside an old pressure vessel, because it doesn't give us the real information. So we should somehow reuse the old ones, so recycling the old samples. So this innovation is about this how to recycle and make more data available from the old samples. This was the basic idea. And okay, so I skip them because these are examples of European projects. Some of them we are coordinating, this one and the last one, for example. And this other example is about innovation in nuclear fuel material. This is the so-called accident-tolerant fuel. It's a kind of outcome of the generation 4 reactor developments, but we probably can use them in the present fleet of reactors. So this concept or this idea offers a possibility to even increase the temperature of a nuclear reactor, or during an accident it won't produce hydrogen. So this is an important break, and then the radioactive material cannot release. So this is what they offer, and there are numerous material science, material testing project behind it. Just one comment on the Generation 4 reactor. Europe is running still Mira and some other Alfred and Allegro projects which aims at using nuclear fuel in a much more efficient way, and even going further to higher temperatures. So the Generation 4 concept is still living, however we don't see too much effort behind it, so the industry is still not very much interested, but for a research project it is excellent. One of the examples is that Allegro we are also involved in. This is a Visegrad collaboration. We founded this V4G4 collaboration together with the Slovak colleagues, UGV from the Czech Republic, this is our institute, and SDBJ is the Polish Nuclear Institute. This is another Czech institute, CVIA, and CEA as a donator, that's the technology provider. CEA also joined us as an associated partner to this consortium. So this Allegro is a European, let's say, scientific project, and time to time the Commission is supporting us. NC2I is about the so-called co-generation I mentioned you, so I don't want to go in detail, but this is an important part of this SMETP vision to using nuclear reactor not only for electricity but also in the heat market. And let me just mention at one slide that of course besides the fission technology we also speak about the fusion, nuclear fusion. Although it's still a science fiction at the moment, so it is at the conceptual and even the laboratory experiment level, but there are also concepts how to create the first demonstrator power plant, which also will probably produce electricity from fusion energy. So this is a European concept. But you all know about the ITER experiment. It's still an experiment, so it is not a power plant. It won't produce any electricity, only physics. And they would like to build up this machine to test the different technology components for the fusion. This community is very strong and also part of the European landscape, and they get much more money anyway than the fission technology. So I won't go in detail because it's not the focal point of my presentation. This is a picture of our laboratory. So in our institute we also have a strong group dealing with one of the technologies. This is a kind of emergency stopping system which can stop the fusion reaction in a very short time. So this laboratory has been built recently in our research institute, and we are very proud of them. And just reminding you that in Hungary you can find one existing nuclear plant with 4 units. It has been made in the early 80s, and they are already extended for the next 10 years from now. And we are speaking about another extension of the license for another 20 years because we don't have energy production anyway. So we are also planning to build new reactors, 2 Russian BVR-1200, but at the moment it's absolutely uncertain what will happen with them. So the government decided to further extend the existing fleet. So this is Takstud is the new project, and we will see how it will goes on. They got the site license in 2022, but at the moment it is not going very quickly, let's say. SMR, we are also studying the possibility to build SMR in Hungary, and at the moment it's just about that level of interest, so there is no concrete movement behind. We have a Budapest research reactor and a small training reactor at the technical university here at the bottom of the line. So the Budapest research reactor is mainly used for neutron physics research. So this is the main purpose of that. And just a quick overview of the nuclear safety research that we do in our institute. As also can say that this is valid for the whole Hungarian nuclear community. So from the basics of the reactor physics up to the large-scale experiment, radiation protection is also on the picture. So we have a strong competence, I guess, in this radiation protection, and we also have some kind of activity in INC, the man-machine technology is important for the nuclear power plant as well. So what we see in the big picture, just summarizing and concluding that from now on we would like to operate the existing fleet, and we have a lot of challenges around them, and we would prepare the using the nuclear reactors on the long run, but we have to solve the question of the fresh fuel and also the spent fuel management. And then what is important that the continuity between the two necessitates a strong policy behind it, and I think it was lacking in the recent years, but we hope that it will change for the positive way. So thank you very much, and enjoy your stay in Budapest.